The universe witnessed an impressive cosmic expansion before the Big Bang, doubling its size at least 80 times in a fraction of a second. Due to this tremendous inflation, the cosmos became sterile and frigid. It was at that moment that the cosmos stopped growing in size and the energy of the vacuum was transformed into matter and radiation, giving way to the Big Bang era, characterized by intense heat and density. During this era, the elemental building blocks that would eventually coalesce into the galaxies and stars we see today were forged. Now, for the first time, the James Webb Space Telescope has peered into the universe's distant past, and we've made a discovery so unexpected that it poses challenges to our understanding of the cosmos. There was a time when the universe did not exist. It was created by the Big Bang, which occurred approximately 13.82 billion years ago, creating the universe and everything in it. Our Milky Way is one of about 2 trillion galaxies that form from the expanding debris of the universe, which are basically islands of stars. Scientists accept that the universe could have arisen from nothing, evidenced by the disintegration of galaxies and the afterglow of the Big Bang detected as cosmic background radiation. The Big Bang did not occur in a specific place, but space-time expanded in all directions. The universe is compared to a growing pie with no single point of expansion. The inflationary vacuum existed at the time of the Big Bang, and its energy increased with its volume. Inflation is considered a free banquet for physicists. The inflationary vacuum grew and parts of it decayed at random, giving rise to the Big Bang. In the vast inflationary vacuum there are infinitely many bubbles similar to our world of the Big Bang. The universe began from a kilogram of inflationary vacuum, materialized seemingly out of nothing thanks to the laws of quantum theory. Although the Big Bang theory explains the expansion and cooling of the universe, it has required adjustments. The existence of invisible dark matter is postulated, which accelerates the development of galaxies due to its gravity. The presence of dark energy is also proposed, which counteracts the gravitational attraction and accelerates the expansion of the universe. To explain the constant temperature of the universe, an extremely rapid initial expansion called inflation, caused by an energetic inflationary vacuum, is posited. Suppose the Big Bang was not the first thing to happen. What was there then? In another of its many successes, the James Webb Space Telescope has returned a stunning image of that tiny location, revealing previously unknown information about the Big Bang. The telescope's goal is to discover light from the first stars and galaxies. It is considered the replacement for the 32-year-old Hubble. Since its successful deployment, it has taken magnificent images of galaxies that formed just a few 100 million years after the Big Bang and moments before a star died. Webb has taken the first direct image of an extrasolar planet and used it to capture impressively precise photographs of the Tarantula Nebula, a region home to hundreds of newborn stars never before seen by humans. The telescope has also revealed new hidden stars and the fine structure of huge clouds of gas called the Pillars of Creation. The newly released image shows NGC 346, an object that is part of the Small Magellanic Cloud, SMC, a dwarf galaxy that lies just 200,000 light-years from Earth. As in many regions of the universe today, NGC 346 was already known as a nursery for young stars. These regions are known to have low concentrations of metals and other elements heavier than hydrogen and helium, making star formation slower than at cosmic noon. Star development is aided by the heavier elements that make up space dust, but due to their low concentration of metals, present-day star-forming areas are assumed to be low in dust. Still, they continue to produce stars, just not as rapidly as when they formed at cosmic noon. However, Webb scans of NGC 346 showed the exact opposite of what was expected: huge dust clouds that accelerate star creation, in contrast to the Small Magellanic Cloud, a galaxy at cosmic noon that would be thousands of NGC 346 instead of just one. according to Margaret Meixner, lead scientist on the study and author of the new image. But even though NGC 346 is now the only major group in its galaxy that is actively generating stars, it provides us with a fantastic opportunity to investigate conditions at cosmic noon. The abundance of dust in NGC 346 supports the hypothesis that galaxies during cosmic noon were equally shrouded in dust, providing a close-up artifact of the early universe. Furthermore, this implies that NGC 346 may be creating planets as well as stars, accreting them from swirls of metallic dust. If that were the case, it indicates that Earth-like planets could have originated at the same time as cosmic noon, considerably earlier than astronomers previously believed. It is indisputable that Webb's new look is yet another surprise from a machine that has been in orbit for just over a year, and has done everything its designers and mission planners have asked of it. This is true regardless of the stellar chemistry and physics at play. This stunning image joins a growing collection of stunning cosmic panoramas beamed back to Earth by the telescope. In addition, the James Webb Space Telescope has also allowed scientists to peer into the earliest times of the cosmos, where they made a startling discovery: 6 huge galaxies that existed between 500 and 700 million years after the Big Bang that started the universe. This revelation has completely changed the way scientists currently think about how galaxies formed. These objects are much larger than expected when looking for galaxies at this early stage in the universe. Scientists expected to find only small newborn galaxies. Instead, they found galaxies just as mature as our own. The telescope uses infrared light to examine the universe, as this wavelength is undetectable to the human eye and can pick up the faint light emitted by ancient stars and galaxies. The observatory can literally go back in time to about 13.5 billion years ago by looking out into the distant universe. What many of us believe to be established science has been upended by the discovery that massive galaxy formation began extremely early in the history of the cosmos. These objects, which we've colloquially nicknamed universe breakers, have so far lived up to their name. Scientists need to reconsider how galaxies began and evolved, since they are so huge that they differ from 99% of the models that describe the early galaxies in the universe. According to the prevailing idea, galaxies began as small clouds of stars and dust that developed over time. This calls into question our current understanding of how early galaxies formed. It is also possible that the galaxies found with Webb's data are something else. It's important that we keep an open mind about what we're looking at, as it's our first look up to this point. Although the data suggests that they are probably galaxies, I think there is a possibility that some of these objects could be hidden supermassive black holes. Whatever the case, the amount of mass we have discovered indicates that the known mass of stars at this time in our universe is up to 100 times what was previously assumed. There are many reasons why astronomers could be wrong. Perhaps the methods by which early stars originated were much more effective than previously believed, fooling Webb into believing that the stars in these galaxies are older than they really are. On the other hand, the James Webb Space Telescope recently discovered and verified the discovery of the oldest known galaxy. The current record might not last long, according to astrophysicist Brant Robertson, who contributed to the discovery as part of the JADE team. The strength of the telescope is such that even older galaxies are expected to be discovered.